All right, I'm actually going to flip this over so we can look. So today we're doing 3.5. We're going to work on it for the second day. So we have percent change and percent error. Today we are going to do the second objective here. We're going to find experimental error and the percent error of a measurement. Okay, and we're also going to do the next one, find the percent difference between two measurements. Okay, and so day 2 over here, you're going to do number 11 through 13, 27 through 39, all odd. So not a whole lot of problems, but make sure that you know the formula that we're going to get to. Okay, so then let's go over to the back and start at example 5. Not example 4, example 5. All right, so notice, I actually want to draw your attention over here to the formula first. Okay, for this. Okay, so experimental error is when we take the experimental value and we subtract the known value for something. Okay, so there's two different formulas here. Then we have percent error. Okay, percent error is when we take the experimental error, and what do these signs mean? What does those bars mean? Okay, that's the absolute value. All right, so that's the absolute value of experimental error, and we divide it by the known value, and we multiply it by 100. Okay, so another way to think about this is percent error is going to equal the absolute value of the experimental error. Well, what is the experimental error? Okay, yep, it is the error. What is the experimental error? Right here, experimental error equals what? Okay, so this is the experimental value minus the known. Well, should be a W, not an M. Sorry about that. Gotta love it, right? No. So that is, right, we're taking this part and putting it inside there. So if we take the experimental value, subtract it by the known value, and then divide it by the known value, my board is glitching, and multiply that by 100, we will get the percent error. Okay, so we can kind of put those two together into one formula if it's easier for you to track it. So, okay, what was that? Okay. So we're going to use this formula, okay, on this problem. So in chemistry class, Jonah determines the density of copper to be 8.83 grams per cubic centimeter, while the accepted value for copper's density is 8.96 grams per cubic centimeter. Determine both Jonah's experimental error and his percent error. Okay, so here's the thing. If we read back through it, we know we need an experimental value and a known value. So which of those is considered the experimental value? The 8.83. Why do you think that's the experimental value? Good. This is the experimental value because it's what he got, what Jonah got. How do you know that 8.96 is the known value? Yeah, that's what he's supposed to get, right? That's the accepted value. Okay, fantastic. Good. So then, how do we find the experimental error? So the experimental value. Okay, so our experimental, I'm just going to put EXP error, okay, is going to equal, you said the experimental value, so in that case that's 8.83 minus the known value. Okay, and what does that equal? 8.83 minus 8.96. All right, so negative 0.13, and it's grams per cubic centimeter. Okay, that's his experimental error. That just tells us he was off by 0.13 grams. Which way was he off? Was he too high or too low? How do you know he was too low? It's in the negatives. Okay, so we also know that this negative means his number was too low. Okay, fantastic.
Perhaps the copper was impure and had impurities in it.
It could have. The copper could have been impure. Absolutely. All right, then how are we going to find the percent error? Okay, I'm going to take the experimental value. Okay, so it's the absolute value, right? Of his experimental value. Well, what was that? The 8.83. Subtract by the known value. Good. Okay, well I need to write, I'm going to divide by the known. Which one's the known?
8.96.
The 8.96. Good. And then what else is in my formula? I'm going to multiply by 100. All right. So wait a minute. Didn't we already do this math? 8.96 minus, or 8.83 minus 8.96? Didn't we just do that? Okay. So we know that that's the absolute value of negative 0.13 divided by 8.96 times 100, if I'm writing it all out there. So what's the absolute value of negative 0.13? 0.13. Absolute values are always positive. So we have 0.13 divided by 8.96 times 100. All right, and that, at this point, you can put that in your calculator, right? You can do 0.13 divided by 8.96. Okay, can I get confirmation on 1.45? That's okay. You don't think it's 1.45?
No, I mean, oh, you multiplied by 100?
Yeah, you should have multiplied because it's times 100 then.
Okay, well, what I got for that one was 0.01. Yeah, okay, so 1.45.
Okay, all right. So 1.45 then, good. And what label should that have on it? No, it's not grams, because what are we looking for here? The percent error. So this, so percent, yeah. Since we're looking for percent error, this is 1.45%. All right. So he was off by 1.45%, which, you know, for things that we think about isn't much. But like if you think about other things, maybe if you were a drug manufacturer, maybe that's enough to make a medicine, you know, like a pill toxic or something. You know, I don't really know. It doesn't seem like 1.45%. It's fine. But that would add up, you know, in different ways and things. So,
I mean, if this is chemistry class and
yeah.
you want the purest form of copper, that is not a really good thing to have 1%. I mean, if it was a larger number, like maybe not centimeters squared, maybe it was inches. Well, maybe it depends.
Well, but see, that's the thing. 1% is still 1%. It doesn't matter what it's 1% of.
Yeah.
Right. So, but I get what you're saying.
If it was a larger amount of copper, the impurity would be spread out more. That's what I'm saying.
True, but it's still the same amount of impurities. So like it's not really spread out more because there's more stuff. So like it doesn't matter if I have, you know, an ounce of it or if I have 100 ounces of it, the impurities within it would still be the same because it's 1%. So it's the percent of the whole. So Well, we were talking, like, I did use medicine as an example, like if you were making medication or something, but then Zane took it back to chemistry class, which is also true.
I like science.
No, that's awesome. I love it. I love it. All right, the next up is a percent difference formula. Okay, so percent difference. The other one was percent what? Error. So there's experimental error, percent error, and percent difference. This is where people get these confused. Okay, so percent difference, all right, is here. So it's the, okay, we have these brackets again for absolute value. So it's the first value, the absolute value of the first value minus the second value divided by the average of the values. How do you get an average? What is an average? Oh, yes. Okay. So if this is a first and a second, you're going to take number 1 plus number 2. Does that make sense? Number sub 1, like the first number and the second number or value, and you're going to divide that by 2. That's what this average is. And then you multiply by 100. So there's a lot of extra little steps in here that we've got to get into place. So in example 6, Suzanne is asked to determine the volume of a cylinder. Using water displacement, she arrives at an answer of 15.64 cubic centimeters. Then she measures the cylinder's dimensions and calculates a volume of 14.01 cubic centimeters. Find the percent difference of her results. Okay, so in this case, is there a known value? No, so we can't, we're not calculating experimental error. She has solved this 2 different ways, and so we're looking at the percent difference in what she got.
And luckily for us, there's no known value in that example equation.
Yeah, exactly. And there's no, that's it, and there's no known value in this equation. So to find the percent difference, we're just going to follow that formula. So we've got percent difference is going to equal the absolute value of, what's the first value?
15.64.
Okay, so 15.64 minus the second value. 14.01. Okay, we're going to divide that by the average of the values. Okay, so are you doing the math on the numerator here?
Yes.
No. Write the whole equation. Put your calculator down. We want to write the whole equation before we start doing any calculations. We want to get everything in place, okay? Because otherwise we tend to lose our spot. So how do we find the average of the values?
We add those two and divide by 2.
Okay, so then we're going to take 15.64 plus 14.01, and we're going to divide that by 2. That's my denominator. Whew. Okay, that's what I'm saying. Like, we want to get everything in place first, and then we can start solving. All right, and then is there anything more to the formula? Multiply by 100. Great. Okay, so now, yes. So now solve your numerator. What is 15.64 minus 14.01? 1.63. Okay, and what's the absolute value of 1.63? 1.63. Fantastic. So that's our numerator. Now, the denominator. 15.64 plus 14.01 divided by 2.
It should be 29.65.
Oh, no, it should not be 29.64.
Oh, wait.
Your calculator...
Sorry, I'm just adding both of those.
Oh, touche. Okay. Fantastic. I'm like, your calculator's only as smart as you. So if you put that all in at once, it will do 14 points. That's okay. But I thought if you put it all in at your calculator at once, it does order of operations. And this does not. Like, you need to add these two first and then divide by 2. Okay. I'm with you now. 14.825. Okay. Can I get confirmation on that?
Yes.
Yes? Okay. All right. And then we're going to multiply by 100. So, what is your solution? Yep, you do 1.63 divided by 14.825 and then times 100.
10.99.
Okay, 10.99, we could round up to 11.
Yeah.
So we could say 10.99, which is 11%. Okay.
This is okay, we round up like on a test or something.
I'll generally tell you, but the tens or the hundreds place is ideal. So we'll go from there. Because I'm also fine with 10.99%. All right, are there questions about using these formulas?
I mean, I understand them now, but I feel like I'm gonna forget them really easily. Like I do everything
This
else.
is a lot of stuff to remember.
It is a lot of stuff. So you're going to need your notes, and then I would recommend getting started on your homework now so that you can ask questions if you're struggling. And do one and check right away. All right.